Yeah, good morning, everyone. Welcome to this section. Uh, my name is Falola. I'm a full stack software engineer. So I deal with creating applications for the backend, APIs, and front end. So today we'll be taking a course into Docker. Okay, thank you.
Did we all get that, or want him to speak a little louder?
Okay.
Okay. So
Increase the
you
volume
you
of the
have the
mic.
best mic actually. So just project a little more.
Okay,
Okay. Yeah.
okay. Good morning, everyone. Is it better now? Okay, yeah. So, as I said, my name is Damilare Falola. I'm a full stack software engineer. So, I deal with creating applications, web applications, the front end, the back end. So, the front end deals with creating the user interfaces, while the back end deals with making APIs, application programming interfaces. I don't know if you can hear me clearly. Okay. So I'll be taking you to the into the world of Docker. I don't know if some of you have had experience with Docker before. Docker or containers. Wow, okay. At least someone should have had experience here before now. So it's very simple and it's very interesting. It's very interesting, and I would like everyone to pay attention because this is the foundation for the second course we'll be taking, Kubernetes. So this will be the foundation. So please pay attention to today's course so that you'll be able to follow in the next course. So it's not changing. So for those that are not from Nigeria, I hope you're enjoying Covenant University. Please, who is not from Nigeria here? Okay, welcome to Nigeria. Hope you're enjoying this place. hope it's fine. Hope you're enjoying Nigeria. Hope you're enjoying Lagos. Abiogun. How is the hotel? It's fine. A little bit. Okay. Okay, I pray you have a nice time in Nigeria. So, but how many of you have a software background, like computer science background? Okay. Maybe I'll pass the mic around and ask your background though. Let me select at random first. Sir, please, what's your background?
Engineering.
It's still close. So you did some program. Okay, maybe I should ask. Anybody has experience with programming? Programming, okay. Okay, that's nice. Let me see, ask. Okay, my gentleman, please, what's your background?
My background. Networking in a distributed system. Yes, but I can do something in programming, Java, C, shell scripting, and Python.
That's very good. That's very good. So you have some programming experience. That's nice. Okay, it's working now. So thank you very much, the technical crew. So this is the outline of the course. So we start with containers. We discuss containers because this is the foundation of Docker. This is what Docker is all about, containers. Then we'll move to importance of containers. Then we'll do some comparison between containers and virtual machines. Then we start with Docker. What is Docker? The architecture, the installation, the command, then building Docker images. This is the meat of the course, like building images. Then we talk about volumes, networks, compose, and we do a real project. So this will be a hands-on program, a hands-on course. We'll be doing some practicals too. So I'll need Okay, before I go there, this is the resources used for this course. So the slides will be given to you. So in case you want to add more knowledge to what I speak on today, you can always visit these resources. You can always use these resources. Please, you're very, very useful resources. So this is the link to the practical. So please, can everyone visit this site and just clone the repo on your system? So we have all the practicals on this link for both for today and for Friday. So it's a GitHub. Yeah, clone it on your system. Using? No, on your system, on your normal system. Okay, you already have the card. That's very wonderful. Yeah, because we will still install it for those that don't have. But try to clone this repo because we'll be using it for our practicals. Okay. Thank you for the information. Let me show you how to do it. You don't need to sign in. Yeah, you don't need to sign in to clone. So this is the repository. This is how it is on your website. By the time you visit the link, this is the way it should be. If you have problems, please raise your hand. 404. You must have omitted something. Okay. .com. No, 845. HPC. Then another C course. So it works. So you can get it in two ways. You can clone it or you can just download the zip file. Yeah. So I think download this zip will be okay. Just download the zip file. Download it as a zip file and extract it to a folder on your system. If you have questions, please just raise your hand. If you have issues. Okay. If you want to clone it, you copy this link. Copy it. Use this link. Then first, do you have Git on your system? Do you have Git on your system? Git. Git. Okay, Git bash. Git bash. That means you have Git. So go to your Git bash. Then copy this link. Then type git clone and this link that you copied here. and just download the zip file. So okay, that means you have it. It's okay. So you have all the course files, all the practicals. Does anyone still have problems downloading it? Okay. Does anyone still have problems downloading or getting it? Okay. No edition mistake. Yeah. Press enter. Yeah. So just click here and download zip code. Yeah. Download zip. Yeah. Test. Okay, so thank you very much. It seems like most of us have it now. So the next thing is we have more downloading to do. I wanted to put this later, but it will be good we start downloading it from now so that as I'm speaking, the installation can be in progress. So the next thing is to install Docker on your system. So I've put in the links for Windows, Mac, Linux, and in case your system doesn't have the capacity, there are alternatives here. So, but first, let's try to install Docker. Download and install. Okay. Okay, I'll put it in a flash. I'm going to say. Okay, I'll have to send it to WhatsApp. Email. Okay. Okay, so let's start. So first, let's deal with the foundation of Docker. What Docker is all about, what Docker does. So Docker deals with creation, maintaining, building, of running of Docker containers. So what is a container? So before we go on, I would like to start with an analogy. So here we have an house container. So what can we notice about this house container? So you can see that it is self-sufficient. Everything someone needs to use to live in this house can be seen in it. So we have the bedroom, we have the bedroom, I think we have the toilet, we have a kitchen, we have a minor sitting room or dining room. So everything about a basic house is in this container. So it is self-sufficient. Everything you need about it. So if I want to, let's say I'm tired of living in Covenant University, I want to go to New York, I can easily transport this container. Though it's a very far place, I can easily transport this container to it. So that's one thing we can notice about container. So all the dependencies and everything about it is all packaged in one unit. Everything is all packaged in one unit. It can be moved. It can be shared as a complete unit. No need to reach out to get something. If I want to cook, no need to reach out to my neighbor's house to go and cook. Everything to live a comfortable basic life is in this container. So we can relate this container into the world of software engineering, to the world of software containers. So software containers is a lightweight alternative to full machine virtualization and involves, see why I put it in boldface, encapsulating an application in a container with its own operating environment and dependencies. So just like we have in a house container, everything is packaged into its own self-sufficient space. So for a software container, the application, the operating environment, and the dependencies are all packaged into one single software container. So containers mostly consist of layers of stack images. All containers has a base image and specifies the operating environment. So the base image specifies the operating environment. Other dependencies are built on top of the image. And containers are expected to yield the same results no matter where they are. So if I move my house container to New York now, it will yield, it is still the same thing that it will be as it is in Covenant University. So if you have any questions, please just draw my attention to it. I don't know if anyone has questions up to now, understanding what software containers are, self-sufficient applications, so that encapsulate the applications and its own operating environment and dependencies. So if you have questions, you can always draw me back. So why are these containers important? Why are they important? What is their use? So let's say we have different installation of an application software in different physical environments. Let's say on a local machine, your local machine, and a remote machine. Let's say we have different installations of an application software. The software you have on your system might be working very perfectly, but the one you have on the remote machine might just, for one reason, not work. Maybe because it has different versions. It might not just work. But with containers, we can lock in a particular version of a software on your system and on the remote machine. So let me give an example. Let's say on your system you have Python 3.7 and you're running an application with Python and it's working perfectly on your system. But you want to move this software, this application to the server. But on your server, you have Python 2.7. So definitely it will not work because the syntax of Python in Python 3 and Python 2 are very different. It won't work, and this can give you a headache because you spent all your time developing it on your system, but all of a sudden, in the production space, it's not working. But with Docker, you can circumvent this issue because with Docker, you can specify the base image. You can install all your dependencies on the container, and you can easily ship it to your production environment, to your remote server, and it will work the same way it works on your system. So that's one importance of Docker, of containers, I mean. So as developers or people working on a project as a team, so let's say we have different people working on a software project in a team. So on team A, member A, he has, let me use Node this time, he has Node 12. And on team member C, he has the latest version. He always like to update his system to the latest version. He has the latest version, but there's a feature in Node, in the latest version, that is not in Node 12. So this can cause issues between people who are programming, who are making a single project. So, but with Docker containers, we can circumvent these issues. We can lock in a particular node version in both teams containers, in both teams applications. So for the third one, for a single developer, you might want to avoid different issues in different projects. So let's say I'm working on a project. So on my system, I have, for project A, I have Python 3 that I'm using, but I want to quickly switch to another project. Maybe maybe a new client calls me and say, please come and help me with this project. I want to switch to another project, but I already have Python 3, but in this new project, I need Python 2. So having these two versions on your system is always causing issues. So, but I need a way in which I can run both projects easily without uninstalling one and reinstalling another one. I need a way to install it. So using Docker containers, it will help me avoid these different issues because I can easily create a Docker image with Python 3 and another one with Python 2, all on the same system without uninstalling one and without reinstalling another. So as I said before, so Docker containers are mostly layers of stack images. We have a base image. So that base image will be the version I want, the Python version I want, or the Node version I want. And other dependencies built on top of the image. So we have the base image. So let's say I want to use Python 3 for my project. I will just specify Python 3 as my base image for it. And all the dependencies I need, I can specify it when using the container. And I expect that this container will yield the same results no matter where I run it. So I don't know if anyone has questions up to now, or if you want me to go over it again. Any questions? So this is the importance of Docker. So I can easily lock in a particular version of a software on my system and ship it to another system, and it will run exactly the same way it worked on my system. There won't be issues because I've already locked in a particular version on that Docker container, and immediately I ship it into another system, it will work exactly the same way. So that's the way Docker works. So you might be saying, what I'm saying, it sounds a bit familiar. I know you guys have done something of virtualization. It sounds a bit familiar to something I've heard before, virtual machines. Like if I want to create a separate system that does one special thing, and have one special version, I can also just spin up a virtual machine to do that. So what is the point of containers, or where does their similarity come together? Because virtual machines almost does almost the same thing like container does. Let's say I have a remote machine that has Python 2. I can easily install a virtual machine on my system to spin up Python 2.0 so that when I'm done with this project on my system, I can easily transport it to the project on the remote machine and it will work. So they seem familiar. What's the difference between the two of them? So as you can see, virtual machines and containers both help spin up independent, isolated environments, which is what we have been talking about. Independent, isolated environment that can be shipped anywhere, that can be moved anywhere, that can have the same impact anywhere, no matter where you install it. But the difference is that containers are much more lightweight operating environments compared to virtual machines, which use full operating system. In the image you see here, we can see the left side, which is a virtual machine. We have the infrastructure. Then we have an hypervisor, which is used for creating virtual machines. That's just it. It's a fancy name for creating virtual machines. So we all have the guessworks. You can see the full operating system. And we can see the application layers on top of the operating system. Then on the left side, we can see our containers. Also has infrastructure, as your operating system, but now as the container engine. You can see it doesn't have full operating system. So it is much more lightweight than virtual machines. So virtual machines, you need to install the whole operating system. I need to install the whole Linux operating system. But on containers, I don't need that. So that's number one difference. Then allocation of resources is not important, is not optimized in virtual machines. So for this, in virtual machines, you need to install all the resources you need, but in containers, you can select specifically what you need, the exact thing you need for whatever project you are using. You can specify only that. As we go along in the project, you will see examples. In the presentation, you will see examples. You can select everything you need, just specifically what you need. But with virtual machines, you have to have all your components for it to work. It won't just say, you can't just say, I won't want, I only want some libraries in my virtual machines. You are installing a full operating system. But in containers, you can just say, I only want this specific library. So that's another important thing in containers. So the third one is that containers, okay.
Please, just the way we've been doing this, when you have questions, feel free to just ask your questions so that you'll be able to bring out things that are not even in the PowerPoint, okay? And if you have ideas that can complement what he's also talking about, please feel free to do that. Let's continue with that same spirit. So like you have a container that was done maybe in Linux, okay? Can you port it to Windows environment, and it will still run smoothly? So just shed light on that.
Okay, thank you very much. So if you have a container, but let me get your question. Do you mean the base image in the container? Okay, with a Linux environment, the base image is a Linux. And so, you know, okay, you know, there are two things here. We have the operating system. Is the operating system a Linux system?
Your operating system is a Linux system.
Okay, then you created a container on the operating system.
On the operating system,
okay.
Exactly.
Okay.
And you want to run that container on
Windows
Windows or Mac OS.
Or Mac OS, yes.
Exactly.
It will run smoothly because you can have the same container engines on both Windows and on both Linux and on both Mac. You can have the same container engines. But what I thought you meant is that, you know, because each container has a base image. So you can specify a base image that I want it to be Linux. I want it to be Windows, because it's it's not very, most people prefer Linux because of its security issues, and it's used among programmers. It's much more preferred among programmers. But we all have the same container engines on the different operating systems. So
Exactly. That's the aspect I wanted you to emphasize.
okay.
That the container engine now on Linux would be different from the container engine in Windows environment. Because when we're trying to install the Docker, for instance, Docker is a container engine.
Yes.
The flavors are different. When you have a link for Windows, you have a link for Linux, you have a link for Mac. You understand?
Yes.
Meaning that there are variances.
Yeah.
As you move from one operating system with respect to the container engine now.
Yes, there are variances, but by the time you run the same commands like Docker create, Docker pull,
At the upper layer.
yeah, they're all similar.
Exactly.
They're all similar. But if I create an image in Mac with the same base, like Ubuntu image in Mac, and I put it on and I transport it to a Windows machine, it will run in as much as it has a Docker engine. So because that's what Docker is about. Sharing, moving a container is one important feature of Docker. So you can easily share an image. You can easily share a container with another operating system. If you take it back to the house container, I can easily move my container from point A to point B. So that's one important feature of Docker. I can easily move my container from Windows machine to a Linux machine. Thank you very much, sir, for the question. So containers can be easily built. I can easily build a container. I just need to specify a base image. We will get to this very soon. This base image I'm talking about, I can easily specify the base image and some simple run commands and the output command for it. Just simple configurations for the Docker container. But with VM, it's not easily, you can't easily build a VM because you have to install the operating system, you have to do some settings. Then sharing a VM too is not easy. Like for example, we did one course, I think last year, on bioinformatics. We needed to install a lot of software. So sharing this VM with everyone in the course all over Africa was a big challenge because it was very, very fat, like a lot of things on it. But if you all have individual Docker containers for these things, it'll have been easier, it'll have been straightforward. So sharing of VMs is not as easy as, like, if I have a VM that I did in Windows, it's not easy to share it with a VM in Linux. Before you can get it to work, it will give you a headache. Before you can get it to work, you have to be some pro-level system administrator to get it to work. So, but with container, it's very easy to share them. It's very easy to move them. It's very easy to work with them. So now, what is Docker? We've been talking about container since, which is the foundation of Docker, which is what Docker is all about. So Docker just helps you to create this container, these containers that we've been talking about. So Docker is a container-based platform for developing, shipping, and running containerized applications. It provides the ability to package and run an application in a loosely isolated environment called a container. Isolated, note that word. Docker makes the deployment of application very fast and easy, and aids continuous integration and continuous deployment workflow. So you can easily create your application and you can easily deploy it because you expect that the way it functions on your system is the way to function in the remote server. You can easily ship your container. So Docker helps us achieve that. Docker makes application highly portable, as we've been discussing, as a container set up on your local machine or virtual machine is a data center. So let's get into Docker architecture. So how does Docker does it work? What does it use to achieve its work? So Docker uses a client-server architecture. Before I go on, who can just help me explain what a client-server architecture is? I know there are a lot of tech people here. Someone should help me. A client-server architecture. What is it about? I will ask the mic to someone. Someone should help me. A client-server architecture. We will not go on until someone speaks. Okay, my gentleman in front.
Okay. Client to server architecture is a network configuration where there are systems that are clients or peers that are actually receiving resources from a server. The server administers resources and controls what happens to other nodes on the network.
Very much. So you mentioned two important things. There are clients and there are server that has resources that share these resources with the client. So that is a very, very good explanation. I still want one person, this time a female, that can help us explain it. That's what I will know that you're understanding. So I want it to be an interactive class so that it's not just one person speaking all the time. Let's try to make it interactive. Just say anything.
I have plenty of food. Okay, you have plenty of food there.
One, please.
It holds and manages resources that the client requests.
Thank you very much. It holds and assigns resources that the client requests. The client sends requests to the server for some resources, and the server responds back with some information. So that's it in a nutshell. So we have a client. He sends requests to the server for a particular resource. I need this particular thing. And the server responds with exactly what he needs. So the Docker client, which is what you can see on the left-hand side here, which is the prime way users communicate with the Docker daemon. The Docker daemon is in the server. So the Docker client communicates with the users via the Docker daemon. To the server via the Docker daemon via REST APIs, so representational state transfer APIs. So it's just like sending data to the server in JSON format, JavaScript object notation. It's just like sending data. So it's a way in which the client speaks to the server, JSON. You just say, okay, X equals Y. Maybe Y means something to the server. So it means give me information with Y. So the Docker client sends information to the Docker daemon, which is the server, that I need this information, I need this, and this communication is done via REST API and network interfaces. So what does the actual work is the Docker daemon. You can see it here. The Docker daemon. So it does the actual work of creating a container, running the container, executing and distributing the Docker containers. So you can see here, let's say I want to build a Docker container. I pass the information to the Docker daemon. Docker daemon does the work. First tries to pull the image and creates the container for it. So that's the way it works. So the Docker registry stores every Docker image that is common. Stores every Docker image. So all these images that we are creating, they need a place to be stored, and they are stored in the Docker registry. So every image we create, we'll be creating images very soon. So they are stored in the Docker registry. So that's what the registry is for. So we can see these are different images: Ubuntu, NGINX, Redis, different images. So they are stored for it, so that next time someone says Docker pull, it goes to the Docker daemon. The Docker daemon checks, okay, is this image in my internal registry? No. Then it goes to the external registry, pulls it. Let's say Ubuntu, it pulls it, and it creates the container for it. So that's the way. So what does the actual work is the Docker daemon. So what are these images that we are talking about? So images are templates with instructions for creating container. Very simple. Templates are just a template with instructions. So we have specific instructions. So Docker has created specific instructions with which we use to create images. So these Docker images are templates with instructions for creating a Docker container. So images has a base image. I've been talking about this base image. So this base image specifies the operating environment. I can make the base image Ubuntu, and it says that means that container will have Ubuntu base image in it, and additional commands for customizations. So to create a container, to create an image, we create it as a Docker file. So we'll be building our own Docker files as the course goes on. And containers are the runnable instance of the image. So let's note it here. There are two different things: images, containers. Images, containers. Images are the templates with which we use to create a container, while containers are the runnable instance of that image. The runnable instance. So we'll be playing with this very soon. So before I go on, have we had success installing Docker? Because we'll be running some practicals very soon. You sure? Do you have the slides now? Okay, I know it's quite heavy. If a few people download it and just share with others. But we'll be running some practicals very soon. Okay, yeah, yes. Exactly. You also have to read if your system can carry it. And there's a Docker playground in that slide. There's a playground. You should just visit that slide. Just visit that link. You have a question? No, this is GitHub desktop. So how many people, please, how many people have installed it? Or currently downloading? Okay, that's nice. Okay, installing. So we'll soon be doing some practicals. So let's move on. So now that we know what the architecture is about, it's time to run some commands. Let's try out some commands and see how to interact with Docker. Okay, so let's continue. I think 80% of us has it. So if you don't have it, there's a playground. There's a playground that you can use to follow. So this link in the slides, this link, labs.play-with-docker.com. So you can just use it to play with it. You can run the commands. And yeah. So I think you need to sign in. When you when you sign in, then you'll be able to use it to. Thank you. No, I have water. I have water. I have water. So let's move on. So now that you have Docker, you can open a terminal on your system. Just open a terminal on your system and type docker hyphen help and see what it gives you. So open a terminal. Open a terminal. No, your Windows terminal or Mac terminal. See command prompt for Windows and terminal for Mac. No, no, just ordinary. Okay, but it's still installing. You can't run the command yet. Docker hyphen help. Docker not found. Did you restart? Have you restarted after installing? Yeah. Have you? Let me see. Open your Docker again. No, you can skip this one. Skip. Yeah, I'm I'm you know, you're saying open your terminal. Maybe you need to restart. Mm, just type Docker. So it's installed now. And then try restarting. Sorry. I hope that will work. Okay. Okay. Ah, sorry for the people that are online. Sorry that I've neglected you. Um, so right now we are trying to install Docker. I don't know if you have the slides. If you have the slides, go to the Docker. No, for the people online. For the people online, if you have the slides, so go to the slide where you have Docker installation and install and click the link for your operating system and install Docker because we'll move into some practical section very soon. So that information is for people online. So open the link, go to the slide. You have Docker installation. I think it's the fourth slide, third or fourth slide. Check or fifth, one of them. Docker installation. Then open the link that is for your operating system, either Linux or Mac or Windows, and install Docker because we'll be using it to for some practicals now. And yeah. So for those online, if you don't have the requirement to run Docker, the last bullet point, yeah, you can use it to play with Docker. Okay, let me just go to the slide on my system. So for those online, this is the slide. I believe you have the slides by now. You should have the slides by now. So install Docker for your operating system. If you don't have the requirements to use Docker, just play with it, but you might not be able to do the advanced. You might not be able to do the advanced tutorials. Okay, it's working for you. Okay, okay, update now. Yeah, it will start. Start. Go to type Docker. Docker. If you have problems installing it for those online, you can ask for audience.
I think I opened two, what's it called? But no, that complaint is saying that something by virtualization. Okay, how do I click on the that's an application. You need to go to your BIOS. That's I think that's what.
It's asking me to install the Linux for the installation.
Okay. Yeah. So, how many people have it installed? Please raise your hand. If you have it installed and it's working, you open your terminal or your command prompt and type Docker, and it prints out the command. Hello, can you hear me? Do you have it installed and it's working? You type Docker, okay, starting update. So if you don't, we'll be going on break very soon. If you don't have it installed, please use the break time to install. Okay, open your terminal, your command prompt. No, open a new one. Okay, you've already typed Docker.
Docker help, right?
Yeah, or Docker. Just type Docker. Yeah,
Are we going on lunch now?
and by one.
By 1 o'clock. Okay, so you are still home.
Okay, it's working. No, just type Docker. Okay, it's working. It's working. Okay, starting. Okay, so we'll be going on break very soon by one. So if you don't have it installed, please use the break time to install it. This is information also goes to those who are online. Please try to install Docker because we'll be taking some practicals very soon. Sorry, if your system cannot carry it, if your system cannot execute it, run it, use the playground link that I put, the last link that I put it in the slide. So you might only be able to run the first practical, the second and the third one. You might not be able to run it. You know, if you have it installed, no problem. But if you don't have it installed, please use this break time to install it. I'm saying it again, please use this break time to install it. If you don't have it installed. Okay, then we start. It's working a bit. Okay, good. So again, I'm saying it again, so that there won't be delay when we come back because this is a big delay. If you don't have it working, please use the break time to install it. The break time starts by 1 and ends by 2. So 1 hour. So you know that you quickly go and eat and you won't waste time eating and you come back. Chap chap. So you use your break time to get it working so that we can just zoom off when we are back. Okay. This information goes to those who are online. Please try to install Docker. I have the slides open on my system and it's presented on the screen. Use this time, break time, to install it and update it. Thank you.
Thank you very much, Mr. Damilare Falola. Yes, so as he said, we'll be going on break right now by 1 p.m. and we should be back here by 2. So by 2, we expect that every installation would have been done and so we can run smoothly from then onwards. Thank you very much.
So there's a WhatsApp group, second HPC workshop WhatsApp group. If you are not yet in that group, kindly signify so that you can be added to that group. Most of the information from the workshop, they are posted on that group. So, okay, you are not yet there. Okay, I will add you now. Is there any other person that is not there? All the PowerPoints from beginning, except for Professor Sabo, and thank God he's right here with us. So I'll get his own too and push it on that platform. Then pictures are already rolling on that platform already. So you can just see either Mrs. Ajayi or myself to be added. Thank you. Enjoy your lunch.